All right, I'm recording now. Okay.
Sounds depressed.
Now I'm thinking I'm expecting it, so now it's going to be like extra in my head. All right, so Circumcenter. This is the first of when you have three segments within a triangle. They all cross somewhere coincidentally, not really a coincidence. And so the first one we're going to learn about is the circumcenter. Okay? All right. So the first blank, okay, maybe you guys can guess. The blank of the sides of a triangle intersect at a point called the circumcenter. All right. So what point is the circumcenter point you imagine in that drawing? It's totally all time. It is point P. It is point P. Ridiculous. All right. So what is intersecting at point P here? What do you imagine? There's a bunch of lines here. What do you imagine they're talking about? The blank of the sides. That's a hint. It's the blank of the sides of the triangle.
Is it midpoint? Oh, okay. Bro.
Okay. That's enough, Riley. That's enough. Twice poorly timed. Okay.
That was not good.
Because the whole class is anticipating, what is Riley what is she gonna press? Okay. The blank of the, you're not even focused. The blank of the sides of the triangle intersect at a point called the circumcenter. What do you guys think? Yeah, it's the perpendicular bisectors. Squeeze the N in there. Dicular bisectors.
How did they get that?
How'd they get what?
The answer.
How'd they get this answer? How'd they know that?
Yeah. It's just
Oh, they knew that because they looked at the drawing and saw, okay, what's intersecting here? Well, this is a perpendicular bisector because it's perpendicular and it bisects it. So is this one, so is that one, and they all look like they're meeting perfectly here.
Oh.
Okay. Now the thing I don't like about this drawing is they have these extra lines, okay? And the extra lines here is what the circumcenter implies. Circumcenter actually has a purpose. And the purpose of the circumcenter is that all three of those red lines are equal. Meaning, the circumcenter is equidistant from the vertices of a triangle. Okay, I think that's one of the blanks here. The circumcenter is always equidistant from the vertices of a triangle. Vertices. Vertices. I'm trying to spell it. I think. Alright, so here we're going to skip this. Name the circumcenter. You guys say it out loud. P. Okay. Name the perpendicular bisectors F, P, D, P, E, P. Great. Name the congruent segments. The red lines are congruent. Okay. Also, they're bisectors, so A, F, and FC are congruent. There is right triangles in here. Pythagorean theorem again could happen in these problems, and you will need to do that. Okay. But as long as you know the red lines are equal. So if you take now, should we practice constructing this? Let's do that. Let's do that. Let's do that. We don't have rulers here, so you're just gonna have to estimate. But can everyone try your best to draw this exact triangle in your notebooks? Okay.
Can I just
Or in the or on your desks.
Can I use an X bar?
All right, I'm gonna pause real quick while we do this activity, and we'll see what it looks like. We're live again. Okay. So I made this triangle for us to try to find the circumcenter of it, just to kind of like solidify it in our brains a little bit. So to do that, you have to find what? I have to have three perpendicular bisectors, right?
Yes.
So here's the midpoint approximately for this line, right? Let me just measure that. That looks a little bit there. Okay. And then draw a line straight up that's perpendicular to it, okay? So that's one perpendicular bisector done. All right. And my second one is this line, and maybe there looks about the center, I guess. It will be off. If your perpendicular bisectors are off by a little bit, it will be off by a little bit. So I guess maybe something like this. Okay, and that's perpendicular. Alright, this definitely looks off. Alright, it looks like almost like they intersect on the triangle. Is that weird or is it just me?
No, it's happening to
I
me
feel like
too.
yeah.
Yeah. Alright. So this is perpendicular. Is that did we just make up a new rule? For right triangles, does the circumcenter must lie on the hypotenuse? Perhaps. It might have just been this triangle though.
But my time.
I don't know if I measured it wrong.
No, yeah, so you just have the off, so even though your third dot would be here, This line probably should be dropped down a little bit, so that way it kind of lies more like there.
How do you like my triangle?
That looks great. That looks great.
Stop.
So this point right here, okay, that mine's a little bit off, but I'm gonna make it bigger to just kind of like make my precision higher, accuracy lower. One of those two things. This point here is equidistant from this vertex and this vertex and that vertex. It's equal from all three of those. Circumcenter is always equal from all three vertices, so it checks out, okay? So hopefully this activity helped us solidify in our brains a little bit more. Circumcenter, perpendicular bisectors, equidistant from all the vertices.
I redrew it and still not.
Well, the point, it has to work out. So we're just gonna assume that your math and artistic skills. Also, your hypotenuse looks curved.
It is.
Yeah, from this angle.
Wow. It's like at the top. Yeah.
Okay, so now I think you guys have enough information to go down to the activities below. I think I assigned all of these problems, so the first one we'll do together, I think. So let's just keep recording. Let's keep the ball rolling here, okay? We're gonna do this first problem over here. And we're not gonna answer these questions. I just wanna fill in everything I know about this drawing, okay? So I'm gonna make it really big on the screen.
And now it works.
It works now because you uncurved your hypotenuse?
Yeah.
Amazing. Those over there, can we maintain ourselves? Because it's sounding pretty silly over there.
Am I the only one that was hearing like a Jeopardy song?
It's the same? Oh, another right triangle? Oh, another right triangle you're saying, right? Draw one where the one leg is like super short and one leg is like super long, like really exaggerate it. And then we'll see if that works out. Okay, the rest of you, we're going to be filling in this drawing right over here.
Not once.
No, you don't need to do this, Rosalie. You have to draw that third triangle. When you finish that task, you may rejoin us, okay? Oh my goodness. Okay, well that's a Z right there. Okay, so let's fill in everything we know based off the fact that I think they tell you in instructions they would have to tell you, right? Z is the circumcenter of triangle TUV. Okay, so Z is definitely the circumcenter. Okay. So what can I fill in here? All right, so this length 15, I believe that's the length of this line right here. So this line is 15. Okay, so that's the 15 they're talking about there. All right. I don't know why we wrote 15 over 15, but so that's a perpendicular bisector, right? Because Z is a circumcenter. So that's a right angle. This is a right angle, and that's a right angle, right? Wait, this length here, 21. Look at that. That's from the circumcenter to one of the vertices. What other segments have to be 21 then?
The one. YU.
No, wait, T and U.
I thought it was TZ.
Oh, T.
TZ is one of them.
Oh yeah, TZ.
Yeah.
That's what I meant.
Okay.
Okay, what's the other one?
UC.
UZ also has to be 21. Yeah, definitely. Okay. So we got the three segments that go from the circumcenter to the vertices are all of equal length, and all of them are 21. Rosalie, you can stop doing that for a second. Are you missing this? I don't want you to miss this. All we have right now is that 21, 21, 21 from the circumcenter to all three
So
vertices.
the lines at the vertices are all equal, right?
Because it's made by three perpendicular bisectors all intersecting to make the circumcenter, yes, the circumcenter must be equal from all three vertices.
Oh.
Now, an incenter won't have that property, or a centroid or whatever. Circumcenter does. Okay? What if they asked me for the length of TW here? Would I even know that? Okay, let me ask you this. What's VY? 17, right? Because it's a perpendicular bisector, so that's both 17. If that's 19, this is 19. But how would I find any of these segments over here? I know 15 for this line. I know 21 for that line. Yeah, that was actually well done. All right, 15 for that line, 21 for that line. How do I find this line? How do I find this line?
Would be.
No one knows?
Which line?
Pythagorean theorem.
VW or
Pythagorean
Pythagorean theorem. Yeah, so this is like, that's your A value, here's your B. So 15 squared plus B squared equals 21 squared. I don't even know if they want you to solve that, but I'm just going to show you that you can solve some sides using Pythagorean theorem. But I think that's helpful enough. Yeah, you guys get that? So you can find all the segments one way or
So
another.
what's TW and WV? What would those?
It would be 21 squared minus 15 squared, the square root of that. So it would be the square root of 21 squared minus 15 squared, which requires some calculator usage. 21 squared is like, I don't know, 440 something.
Okay.
And
I know
15
I
squared
did.
is 225.
Okay.
But I don't know if they're even asking you for that. So check this worksheet. If it's not asking you for that, don't worry about that
It's
length.
441.
441. So 441 minus 225 and the square root of that. So that's 2, 1, 6.
Let me see.
Square root of 216. But that's not a perfect square.
If they're asking
It's
for like,
206.
if
Oh,
they're
06?
asking for like TU,
Oh wait, no. 216. 216.
if they're asking for TU, do you just add 19 and 19? Or no?
If they're asking for TU, 19 plus 19.
19 plus 19.
Yeah, exactly.
Okay.
So, yeah, I want you to be able to decipher what goes with what, and you should be able to, I think it's not too hard once you realize.
My triangle.
You finished it? Did it? Was it also in the hypotenuse again? That might be a theorem. That's pretty cool. Okay, guys, if it's a right triangle, it looks like the circumcenter will always appear on the. That's weird. But at the same time, not weird. Wait, are you telling me that in a 45-45 right triangle, I'm still recording, but that's okay. 45-45 perfectly right triangle, that the circumcenter is going to be here, meaning that the length from here to here, and here to here, and here to there is all going to be equal? If that's the circumcenter, then that means if you bisect the hypotenuse, that point that bisects the hypotenuse must be equal from both of those points and from the third vertex.
That makes sense.
But that's kind of crazy though. Wait, hold on, let's map this out, ready? We can kind of figure that out. So if this is 2, that's 2, this is 2 root 2. And this over here should be, well, half of 2 root 2, which is root 2, and root 2, and that's root 2. But does that make sense if that's root 2? Because this is now a 45-45. So root 2 times root 2 is 2. So it makes sense. That's pretty cool. Okay. That was fun. For probably me and
So fun.
maybe one other student. Okay, we're done.